In this module, we'll be covering the application control features. We will be covering how to create application control lists and how to use them on your traffic. Application control attempts to identify your network traffic by looking at the packets in order to figure out what software is generating them. Application control tries to monitor or prevent the software you want and don't want inside your network. For example, with application control, it is possible to prevent users from using their Gmail accounts. Like anything else, you need to set up the rules for what you want to monitor and what you want to prevent from the list of applications that are available with this feature, which is quite extensive. You can even use application control to rate limit the traffic it detects. This is something that is covered in more detail on the 301 course. You can view the full list of applications and categories from either the FortiGate GUI or the FortiGuard website. But the list that you create dictates what the FortiGate will be looking for. Each entry on the list can be configured differently to block or only log, whatever the situation demands for that software. When you upgrade the firmware or obtain a new device, it will come loaded with a default database that is very small. Be sure to update and run an AV IPS update, as application control is part of the IPS update. You can add new applications by requesting them on the Fortinet website. Keep in mind, though, that just because you ask for them, it does not guarantee that they will or can even be added. In order to be a candidate in the first place, the traffic has to be unique and identifiable at the packet level from other traffic that occurs on the same port or over the same protocol. The configuration for application control is a two-step process. First, you need to put together the profile that details all the software and actions you want to take with them. Once you have the profile, you need to enable it on the firewall policy you want to monitor for this traffic. Here's an example of the Facebook chat signature. You can see it here in the list, and from there you can click the name to go to the website in order to confirm exactly what the signature is. You can then enable it in the application sensor. It is important to know what a signature actually does and not just make guesses by looking at the name. For example, application control has a signature called LoginAny. What this signature does is detect the use of software called LoginAny. As you can see, someone could easily misinterpret this name to mean any kind of login. It is therefore really important to look up the signatures in order to find out exactly what they are meant to detect in the first place before you attempt to use them. You can click the link in each signature to bring up the tooltip. You can also click the link in that tooltip in order to go to our FortiGuard website and read a more detailed description. Packets that are subjected to application control are inspected with these rules from the top down. In this example, Rule 1 says to look for and monitor everything and log it. Rule 2 says to block Skype, but this will never happen because Skype matches the first rule. This is the exact same behavior as with firewall policies. Your filters can be set up on a per application basis or on a group basis. You cannot have an application sensor that contains too many entries, so your best approach is to have generic policies to block the applications you want, like peer-to-peer. If it is not something you are actively investigating, there is no reason to log it, since you would only be wasting your resources. The unit comes with two implicit rules. They are implicit 1 and implicit 2, and by default they are enabled. Implicit 1 is a rule that, if enabled, will inspect your traffic to see if it matches any known application control signatures. Implicit 2 will make logs for anything that does not match a known signature. These show up in the logs as unknown application since the FortiGate unit does not have a signature to match. They are very useful if you are investigating your network to determine what exactly is going on and where your bandwidth is being consumed. You may choose not to log traffic that triggers these sensors in order to free up logging resources until you require this information. Also, just because traffic cannot be identified does not mean it should be blocked. You need to decide which traffic you do and do not want to allow within your network. The first thing to figure out when you create or modify a filter rule is how specific to make it. To set up a generic filter, you simply enable or disable the options you want. The more you know about what is in your network, the more specific you can make the detection. You can also use the Specify Applications option if you know exactly what you are looking for. It allows you to pick from the list. When you set up the rules you want, what you'll see below is a list of the signatures this filter will wind up applying, as well as a total number. If this is too high, make your filter more specific, remove some operating systems, things like that. Finally, at the bottom of the profile, you decide on an action. If any of the listed signatures occur, what should the FortiGate do? Monitor it with a log entry, block it, send a reset packet, or apply traffic shaping. You can view the categories on the unit, but the easiest way to investigate and find out what is available for detection is to use the FortiGuard website. All the software categories are listed along with descriptions to help further clarify what it applies to. Application detection is like virus scanning. Most applications change their traffic patterns over time, so if this is a feature you intend to use, you will need to keep it updated with the automatic updates. Otherwise, it will become less effective over time, just like outdated virus signatures. It is also important to properly identify how a piece of software works. For example, this is the article for Google Talk, which is an instant messenger software with its own signature. Now take notice in the recommended action. It mentions the software actually uses Jabber for communication. So depending on how your application control rules were set up, you could be allowing Google.Talk and still have the software fail and the logs would show Jabber. It's very important to properly research the software you need to keep a careful watch of. This could involve using the internet to find more information and or making test policies. As well, you should test everything to see if anything will get through or get blocked when you do not want it to. Application control allows you to inspect and apply access restrictions for 4 major IM software packages, including MSN, Yahoo, ICQ, and AOL Instant Messenger. This is handled on the FortiGate device using a single Instant Messenger proxy. Application control is used to identify the traffic, which is then handed over to the proxy for management. Something to keep in mind is that there are no standards for the communications protocols for this software. There are no RFCs or any public standards of any kind. This means that in order to create this proxy, Fortinet developers had to reverse engineer the protocols. It also means that vendors of this software can rework their code for any reason and at any time without telling anyone. This is something to keep in mind if you intend to use application control for IM applications. Normally, when application control is enabled, it is handled by the IPS engine, so it works the same way as flow inspection. There is no proxy, just patterns matching the packets as they pass through. The difference in the case of these IM software products is that in order for the FortiGate device to provide inspection of this, it needs to make use of a man-in-the-middle proxy. With MSN, ICQ, AOL Instant Messenger, and Yahoo, The software is communicating with a FortiGate device, which is pretending to be the server. The FortiGate device then interfaces with the real servers, pretending to be the software. Application control is just a feature used to identify the traffic. This is a look at the options for IAM inspection for a specific application. You can choose to block it entirely or just block certain aspects of its use, like file transfers and voice calls. Because the options for these 4 instant messenger applications are so different from everything else, and because they are the only ones that engage a proxy, they are separated from the normal instant messenger group category. While they are instant messengers and technically part of the IAM group, in order to enable inspection for them, you must explicitly select them from the application control list. The reason is quite simple. There is no exempt option in application control, so if you were scanning all IAM traffic and there was a change in only one of the applications which was causing problems, the only way to bypass inspection would be to manually list all 150 or so instant messenger applications except the one causing the issue. The default policy for IAM is to allow all users. Access is restricted based on the application control profile. You can change the policy to deny all users except the ones that you configure. If your policy is to allow, you cannot block based on IAM usernames. The GUI can be used to create IAM users on the FortiGate device, but only once you have created the first IAM user from the CLI. Afterwards, the option appears in the GUI to create additional IAM users upon your next login or browser refresh. The username will match whatever is used to log into the service. The protocol will match one of the 4 IAM options, and the policy will only be effective if you change the IAM policy to deny in the CLI. Otherwise, the unit will only look at the username for the purposes of log entries. With an IAM policy of allow, this block user policy will never get processed by the device. Again, the user list will only be checked if the policy is set to deny. Once you create an IAM user, an additional option will show up in the GUI which allows you to monitor the IAM proxy. It displays a list of users that are logged in and the instant messenger application they are currently logged into. You can adjust the filters to display only the users that are logged into a single application by changing the protocol. You can also adjust the users list to display only online users or blocked users. You can also use application control to perform traffic shaping for the purposes of limiting a particular kind of traffic. This is very useful when you are trying to limit traffic that cannot be separated using port numbers in a firewall policy. Some high traffic websites like YouTube or Facebook can be traffic shaped in this way. Let's say that you enabled application control because you wanted to investigate a bandwidth issue inside your network. Users had been complaining of slowness, and during peak times, resources were maxing out. During the investigation, you found that many of the users were using Netflix, especially during these high traffic times. You could rate limit them. Because Netflix is just web traffic, you could not separate this traffic using a firewall policy by port or destination IP, since the destination is distributed. You could create a shared traffic shaper to apply to Netflix and then use application control in order to limit the total amount of traffic that is allowed to use. This would keep it from saturating your network. You can do the same with YouTube videos or any other application control entry utilizing the bulk of your network resources. Before applying this, however, you should carefully consider what you are applying it to. For instance, if the situation was different and you found that FTP traffic was the main cause of the bandwidth issues, there would be no sense in using application control to identify that. A policy for port 21 traffic can identify FTP traffic using fewer resources than using application control. It is a very simple reality that most people do not actually understand how the software they are using actually works. To illustrate this, let's try a little experiment. How does this feature actually work? Essentially, it scans traffic passing through the FortiGate looking for patterns. It's really just as simple as that. A particular application entry, like Google Talk, is just a series of transmission patterns in the packets that identify the application. What that pattern actually is obviously needs to be unique for the application. Otherwise, you can only use a generic signature. Not every application behaves in a special fashion. Many of them simply use pre-existing standard protocols and communications methods. This is not an active scan of either system. Doing this would require software to be installed on either end. It's a passive scan of the traffic patterns and nothing else. One of the most often used aspects of application control is the ability to detect, monitor, and prevent peer-to-peer software. This keeps all of those torrents from chewing up your network bandwidth. For those who are not aware of how peer-to-peer file sharing actually works, here's a brief explanation. Standard file transfers happen between a single client, single server with a defined protocol over a set port. Be it a website or an FTP site, it is easy to detect and limit by the fact that there's only one sender and one receiver. Easy to detect and easy to limit. Also, because you only have a single server, in order to get high transfer speeds, you need to invest a large amount into the server hardware. This also helps keep speeds reasonable. Peer-to-peer transfers a single file using multiple, theoretically unlimited senders. So imagine if you had 15 different devices all sending you different parts of the same file. Neither one of these devices needs to be very powerful, but the effective speed you will get quickly outperforms the alternative. Also, since there are no maximum number of devices that can send you files, this can quickly consume huge amounts of network bandwidth. But this still does not answer the big question: why is peer-to-peer traffic so difficult to detect? When HTTP and other protocols were designed, they were built to work. Designers did not care if they were easily detectable. What they wanted was for it to be distinct from other protocols. When the peer-to-peer protocols were designed, the designers wanted them to be incredibly hard to detect, so things like port randomization and sudden changes in the traffic and encryption patterns were built into the behavior as standard. They are hard to detect on purpose because they have been built to be hard to detect. The protocol shifts and changes actively in order to avoid detection. Now it's time for the labs. This time we'll be working with application control. Exercise 1 will have you set up and try out an application control list.